Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is logarithmic differentiation. I have posted the formulas that are used to find the derivatives of logarithmic function. Logarithmic differentiation is a very useful method to differentiate some complicated functions which can't be easily differentiated using the common techniques like the chain rule. It can also be employed for the functions that involve many terms that need the application of the product rule or the quotient rule multiple times to be differentiated. This technique greatly simplifies the process of differentiation as well as the solution so obtained. In physics, error calculations for experiments are usually done by the log error method, not the normal derivative method. Okay, let's find out more about the logarithmic differentiation in this video. Let us see the method of logarithmic differentiation. Here are the 4 steps that we follow to find the differentiation of the logarithmic function. Step 1. Take the natural logarithm of the function to be differentiated. Step 2. We have to use the properties of logarithmic function so that we can distribute the terms that were initially accumulated together in the original function and were tough to differentiate. And third important step is to differentiate the resulting equation. And finally, we will be multiplying the equation by the function itself to get the derivative. So these are the steps to find the differentiation of a logarithmic function. Please have a glance over this. Now let us see common mistakes that happens while finding the differentiation of logarithmic function. Let me show you some examples. The problem on the board illustrates the process of logarithmic differentiation. It is a means of differentiating algebraically complicated functions or functions for which the ordinary rules of differentiation do not apply. For example, please look at this formula. You'll be asked to differentiate expressions where a variable is raised to a variable power. An example and 2. Common incorrect solutions are, please look at the solution. Here we have a variable in the base and also we have one more variable in the exponent. This is a complicated problem. If you apply the general formula, you are applying the power rule. You keep the power here and subtract 1 from this and you'll be getting this answer. This is wrong. Let me show you one more answer for this one, for the same problem. So, both these solutions are incorrect. Am I right? Yes, both of these solutions are wrong because the ordinary rules of differentiation do not apply at all. Logarithmic differentiations will provide a way to differentiate a function of this type. It requires deft algebra skills. I mean careful use of the following unpopular but very well-known properties of logarithms, the formulas that I posted initially. Though the properties and methods are true for a logarithm of any base, only the natural logarithm will be used in this problem set. These are the important formulas that we used in derivatives of logarithmic function. Now let me give you the properties of natural logarithms. Here are the properties of logs and natural logs as well. Please have a glance over this. I have a value for the base e. E is approximately equal to 2.71828. If you round it, you will get 2.71828. You can use that. Please look at these properties. Natural log of 1 is equal to 0, log of e is equal to 1, natural log of e raised to x is equal to x. This will be applicable in many of the problems. Same way, e raised to ln x is equal to x. This is something like opposite operations. E and ln will get cancelled out. This property will be useful when you want to bring down the variable from the exponent's place. In case if you get any problem like a variable in the exponent's place and you want to solve for the variable, you can use this law so that you can bring down the variable from the exponent's place to the base. And same way, the same concept is applicable here for the logs also. These are the important properties of log and natural logs. Now let us discuss the commonly made mistake while doing the problem using log and natural log. I am going to post the mistake and the correct one. Generally, many students make mistake in this formula only. ln of x plus y equal to ln x plus ln y. But this is absolutely wrong. ln of x times y, the product, natural log of the product is equal to ln of x plus ln y. This is the correct one and this is the very commonly made mistake. Now let me post the second mistake. Second important one is ln of x minus y equal to ln of x ln of y. This is what many students write. But actually ln of x over y is equal to ln of x minus ln of y. If it is the ratio, or you can take it like If it is a fraction, then you can imply negative sign in between. And same way if it is a product, plus sign in between. These are the wrong concept students mostly apply. These are the correct formulas. Now let me post the third one. ln of x times y equal to ln of x times ln of y. This is also a wrong step. X divided by y. Some students directly apply ln for each of the term in numerator and denominator. Same way, ln of x over ln of y equal to ln of x minus ln of y. Please compare these two. There is so much difference between these two. Actually, ln is outside the fraction x over y. But here, ln of x divided by ln of y. These two are separate functions, not the same function. So this formula is not applicable here. Please have a glance over the commonly made mistake while doing the logarithmic differentiation. So hopefully you will avoid all these mistakes. So before starting with any logarithmic differentiation problem, please have a glance over the formula list and then you proceed with that. By comparing these two, you can understand the difference between these. Hope you can avoid all the mistakes. It is very important to not get all of these confused. It is sometimes easy to get these various functions confused and use the wrong rule for differentiation. Always remember that each rule has very specific rules for where the variable and constants must be. For example, power rule requires that the base be a variable and an exponent be a constant, while the exponent function requires exactly the opposite. If you can keep straight all the rules, you can't go wrong with these. Let us start with a simple basic example. Please look at the board. Y equal to x raised to x. We have to differentiate this. We have seen two functions similar to this at this point. Okay, I'm going to first show you the rules. These are the general rules that we apply when we get a function with an exponent. This is the power rule and this one is the another rule. But please compare these rules with the question. In this rule, we have a variable and a constant as an exponent. But here we have a constant as a base and variable as an exponent. But these two does not match with this. Neither of these two will work here since both require either the base or the exponent to be a constant. Am I right? In this case, both the base and the exponents are variables. So we have no way to differentiate this function using only known rules from the other topics. Okay. With logarithmic differentiation, we can do this however. First, take the logarithm on both these sides. Please notice that if you want to bring down the variable in the exponent's place to the base, you have to apply only logarithmic rule. First, take the logarithm of both sides as we did, as we seen in the formula set. Okay, ln of y, ln of x raised to x. Now, for this one, if you apply this, take this natural log, this will be shifted to the coefficients place. So, right side of the equation would become x ln of x. Now I'm going to do the implicit differentiation. Differentiate both sides using implicit differentiation. We will get ln of y is 1 over y and finding the derivative of y is nothing but y dash. So 1 over y times y dash is y dash over y. Now here we have a product of a function x and ln of x. So first find the derivative of the first function and then keep the second function as it is. Plus sign in between, keep the first function as it is and find the derivative of second function. This is nothing but the product rule. So derivative of x is nothing but 1. Same way you have to find the derivative of ln of x. 1 times anything is the term itself. X times 1 over x is 1. So ln of x plus 1. Cross multiply. So y dash equal to y times ln of x plus 1. And now question. We got y equal to x raised to x. So we are going to substitute back that in for the place of y. That's it for this example. This is how we do the differentiation of any logarithmic function. In some cases, we may not be able to apply the rule directly. So if that is in that case, you have to split the complex function into some simple functions so that you can apply many rules at a time, like chain rule, something like that. We'll close this video out with a quick recap of all the various ways we will be using along with the logarithmic formulas to differentiate any function with exponents. These formulas are important not to get all of these confused. Please look at the first rule. Derivative of a raised to b is equal to 0. This is a constant rule. And here the second rule is x raised to n. This is a power rule, and the third one is the derivative of an exponential function, and fourth one is the first example we just solved just before. This is the formula we use for logarithmic differentiation. So please have a glance over all these four formulas. These are formulas used for different concepts. So whenever you get the concepts like both are constants, the base and the exponent, you can use this formula. So you have to have a glance over the formulas and identify the difference between each. So you will be applying these rules without any confusion. So this is all about the logarithmic differentiation introduction. In our next video, we can see some complicated examples as well as the basic examples. Hope you're clear with this concept today. See you in the next video. Have a